there, Mr. Sutton here, bringing you the Algebra 2 2-1 Part 2 homework solutions on transformations of quadratic functions. For this first problem, we're trying to perform this transformation on x squared. So for all of these, we're going to be describing the transformation first, writing the parent functions table, which for all of these is just x squareds, and then we'll see what rules we actually need to make this happen point by point. So since I'm subtracting 4 inside, the inside part of it makes this a left-right horizontal change, and it also means since we're inside, it's going to be inverse of what we expect. So if we're subtracting 4, that's actually moving our function 4 units to the right, not the left. So this is a 4 to the right translation. So let's write the parent table here for x squared. That's going to be negative 2 comma 4, negative 1 comma 1, 0, 0, 1, 1, and 2 comma 4. And that's what I'm going to use for the rest of these homework problems where I have to graph something. So we won't go through it in detail every single time. Now for the g function, to transform this, I'm going to rewrite the x and the y with some rules. Since I'm going right 4, that means all my x values need to get 4 added to them. So x plus 4 is the rule I'm actually going to use. And since nothing happened outside the function, there's no vertical changes, I'm going to keep y the way it is. So all these y values will be preserved with the transformed function. So adding 4 to all the x values, negative 2 plus 4 gives us 2. Negative 1 plus 4 is 3. Then we have 4, 5, and 2 plus 4 gives us 6. And again, the y's are just staying the same, so we still have 4, 1, 0, 1, and 4. All right, let's graph these out point by point. So we've got the point 2 comma 4 right there, and then 3 comma 1, 4 comma 0, 5 comma 1's right here, and finally 6 comma 4 up there, and then just draw the parabola through those, and we're all set. For this problem, taking a look at the transformations happening here, the minus 7 inside is shifting us right 7 rather, and the 1 outside is shifting us up by 1. Outside changes, remember, are up, down, and they're exactly what they look like. So we have a translation right 7 and up 1. So here's our parent table again, all the points we used on the last problem. And now for the g function, the new rules we're using, right 7 means we have to do x plus 7, and up 1 means we need to do y plus 1. So that's what I'll actually do to all these x and y values. So we've got negative 2 plus 7 is 5, negative 1 plus 7 is 6, 0 plus 7 is 7, then we have 8, and 2 plus 7 gives us 9. Now we have to add 1 to all the y values, so 4 becomes 5, 1 becomes 2, 0 becomes 1, and then the next two are just going to be 2 and 5 again because it's the same values we had earlier. So now let's graph all these points. We've got 5 comma 5 right up here, 6 comma 2, 7 comma 1, 8 comma 2, and finally all the way over here 9 comma 5. And there's our parabola for this one. For this problem, we've got 1/5 x squared minus 4. So in terms of transformations, this 1/5 is giving us a vertical shrink, and the minus 4 is a translation of down 4. These are all outside changes, so they affect the vertical. Here's the x squared parent table, all those points for reference. And for the g rules here, since it's all vertical transformations, we're doing nothing to the x, so that's going to stay the same. For the y's, we have to do 1/5 times all the y values and then subtract 4. So 1/5 y minus 4. So the x's, this is the easy part. These are all the same. Negative 2, negative 1, 0, 1, and 2. For the y's, we'll need to do a little bit more work here. We have 1/5 times 4, or 4/5, minus 4. And I'm going to call that minus 20/5 just to get a common denominator. So that'll give us negative 16/5, which is about negative 3.2 if you make it a decimal. Plugging in 1 now, this is going to be 1/5 minus 20/5, or negative 19/5, which is roughly negative 3.8, just good numbers to have in the back of our minds. Plugging in 0, I just get negative 4 back from all that. And then plugging in 1 again, I still get negative 19/5. Plugging in 4, I still get negative 16/5. All right, let's go ahead and try to graph this. So we have negative 2, and we said about negative 3.2-ish right there. Negative 1 and negative 3.8-ish right there. 0 comma negative 4. And then same y values, but at 1 and 2 instead. And then let's draw that little smiley face going through those, and we're all set with this one. For this problem, we've got a lot of transformations going on. This negative 2 outside here is giving us two things. It's giving us a vertical reflection and also a vertical stretch. And then we also have some translation going on. The plus 1 inside gives us a left 1 translation, opposite of what you'd expect with a plus there. And then the minus 2 outside is exactly what it looks like vertically. We're going down 2. So left 1 and down 2. So here's our parent table right here. And we're going to modify all these points that we use all the time now. So here's our new rules. Since we're going left 1, x minus 1 is going to be the rule for the x values. And we have a few things going on with the y values. We have to multiply them by negative 2 to reflect and stretch them. And then we have to subtract 2 to get that translation of down 2. So negative 2y minus 2 is the rule for that. For the x's now, let's subtract 1 from all these. So we've got negative 3, negative 2, negative 1, 0, and 2 minus 1 is 1. Now for the y's, it's a little bit more involved. We have a negative 2 times 4, which is negative 8, minus another 2 is negative 10. Then negative 2 times 1 is negative 2, minus 2 is negative 4. This is just going to be 0 minus 2, or negative 2. And then the values repeat because we're using the same y values. So we've got negative 4 again and 10, negative 10. All right, plotting all that out. Since I have to do these 10s here, I'm thinking I'll make my grid lines go by 2's on the y-axis. I only need 1's for the x-axis though. So graphing these points, we've got negative 3, negative 10. That's right about down here. And negative 2, negative 4 right there. Negative 1, negative 2. And then going back down, we have 0, negative 4, and 1, negative 10. And there's our parabola going through those points. On this problem, we're trying to write the rule described by these transformations here of the x squared function. So we're going to do these one transformation at a time. I'm just going to write a different function to handle each transformation. So the first one we've got is this vertical stretch by 4, and reflection in the x-axis. Those can actually be treated as like one big change because I just have to multiply the original function by negative 4. The negative gets me the reflection. The multiplying by 4 gets me the vertical stretch. So I'm going to write a g function that's just going to equal negative 4 times f of x. And since f of x is just x squared, this is just negative 4x squared. So the only other thing they wanted us to do was a translation of 2 units up. So I just need to add 2 to the g function now. And I'll call that the h function. So g of x plus 2. And then since g of x is just this expression here, I can write this as negative 4x squared plus 2. Now they also wanted us to identify the vertex based off of this new rule here. So this is really kind of like having an x minus 0 squared. So we have a 0 for the x value of the vertex. And the plus 2 just gives us 2 for the y value. So 0, comma 2. For this last problem, we have 8x squared minus 6 and a whole bunch of stuff going on with that. We have a horizontal stretch by a factor of 2, a translation, then a reflection. So let's do the horizontal stretch first. I'll call this the g function. To stretch by a factor of 2, I need to multiply the inside x here by 1/2. It's opposite of what you'd expect because it's an inside horizontal change. So g of x is going to be f of 1/2 x. So plugging 1/2 in for x in the f function here, we can call this 1/4 x squared. And 8 times 1/4 x squared is 2x squared. Might as well simplify that now. It's not going to get nicer otherwise. Next thing they wanted was a translation of 2 units up. So I have to take this g function I just created and add 2 to that. And I'll call that the h function. So I've got this 2x squared minus 6 plus 2 now, which leaves me with 2x squared minus 4. So not a whole lot to do to simplify that. Lastly, I want to reflect that in the y-axis, and I'll call this next one the j function. To reflect in the y-axis, that's a left-right horizontal reflection, so I need to negate the x value of the input. So I'm going to write j equals h of negative x. So I'm just going to take this 2x squared minus 4 and plug negative x in for x. Now doing that, if I actually simplify and square that, I just still end up with 2x squared minus 4. So nothing actually changes visually or formulaically with that last reflection. Now the other thing they wanted was the vertex. So this is really like having x minus 0, which is just 0 for the h value of my vertex, the x value. This minus 4 is giving me minus 4 for the y value. So 0 minus 4 is our vertex.